In this video, we're going to use a normal video camera running at 30 frames per second to measure the distance that an object is thrown off of a dynamics trolley. The basic setup is a ramp with a trolley rolling down it and an object on top of the trolley that will be thrown. So let's watch a short piece of the video to show you what's going to happen. The basic idea here is to try to find out from the video exactly where that object was when it first touched the ground. The idea being that the distance that it's thrown is somehow related to inertia. So we're going to use the QuickTime program to run it back, and you can see that at 30 frames a second you get a significant amount of blurring that you don't get with something like a GoPro running at 120 frames per second. On the other hand, with the GoPro and the fisheye lens effect, you get a significant amount of parallax error. So you win some, you lose some. So let's run this back and forth and see where it touches. It has clearly touched down there. It has clearly not touched down there. So I'm going to take that as my touchdown point. I'm going to go back to using my Active Inspire software, which allows me to draw some lines and try to figure out how far this particular object went. First, let's remove those annotations from the earlier video. Now, if I could just point a couple of things out before we start. This meter stick was set up with 100 at the end of the ramp. So therefore, if something reaches 80, that means that it has gone 20 centimeters. Now, if I use my line drawing tool that doesn't draw parallel lines exactly, I'm going to see if I can figure out where that touched down. Now, one thing I have to be careful of is that we do have parallax error. Right here in the middle of the screen, directly in front of the camera, everything is exactly moving straight in front of you. But if you go far to the left or far to the right, you get that perspective effect, and that will give you some parallax error. We just have to do our best to compensate for that. I think, based on what I see, that the can has touched down about there, and that the parallax error, if I compensate for it, leads me to about that point right there. That therefore looks like 10 centimeters, 11, 12, 13, 14, 15, 16, 17, not quite 18, I'll say 17.9 centimeters that the can has traveled after it left the trolley.